Let's return to This Week in America. Here's your host, Rick Bratton.
Welcome back, everybody, coast to coast, This Week in America. Thank you for spending some time with us on the program today. A detailed mathematical derivation of space curves is presented that links diverse fields of superfluids, quantum mechanics, Navier-Stokes hydrodynamics, and Maxwell electromagnetism by a common foundation. That's all in the book, In the Theory of Quantum Torus Knots, Its Foundation in Differential Geometry, Volume 1, by our guest on the program, Michael J. Ungs. The basic mathematical building block is called the Theory of Quantum Torus Knots, or QTK. Michael, born in a small farming community in Iowa, obtained 2 degrees in aerodynamics and aerospace engineering, worked in a wind tunnel, obtained a PhD in forestry physiology, helped start Brazil's first credited PhD program in groundwater pollution. He's a principal scientist specializing in developing mathematical and statistical models of chemical and fluid transport in groundwater, surface water, soil, and atmospheric media. Michael, his wife, 2 children have made the Bay Area of San Francisco their home for the last 35 years. Michael Ungs, author of The Theory of Quantum Torus Knots, Its Foundation in Differential Geometry, Volume 1, is our guest on This Week in America. Michael, welcome to the program, sir. It's great to have you with us.
Welcome you too.
It's always fun on this program to learn something new, and I'm going to learn something new on the program today, and I'm looking forward to having this opportunity. First of all, I mentioned torus knots. That's in the title of the book. Talk about that. Give us a definition, maybe a visual definition of what that is, so we have an idea what we're talking about and what you're addressing in your book.
Well, actually, we'll start with knots. A knot is actually a string to which the 2 ends are attached, and that becomes a knot. And then you can have the string can be wrapped and coiled and whatnot, but the key thing is that it forms a continuous loop. That is what we call a knot. A torus is the best image of that is a donut with a hole in it. Imagine a solid donut with a hole. Now you take your string and you loop it through the center eye of the donut, and you wrap your way around the edge of the donut. At the end, you join the ends. That is called a torus knot. There are many shapes. There are many possible knots on that donut you can form, but they have that unique feature of wrapping themselves around an object that looks like a donut.
The title of the book is The Theory of Quantum Torus Knots, Its Foundation in Differential Geometry, Volume 1. Michael Ungs, by the way, the author, our guest on the program. Why did you use the word quantum in the title?
Well, I remember I just used the analogy of a string that loops through a donut. And these strings are actually very, you have to imagine them as being very rigid and very stiff strings. And therefore, if you have a fixed length of string, there actually is only a certain number of combinations of looping through that donut it is possible that the ends will join again and that there's no kinks in that string, and that there's no sharp bends or intersections. And so there's a unique combinations of knots for a fixed length of string. And that for that reason, they're called quantum, because it's a finite number. There's not an infinite number of combinations. Actually, give you an example. I use it for myself, but I have, if you can see this, a soft string, which forms a trifoil. I just took a coil, looped it, and that is, you can make a heart-shaped trifoil, or you can bring it closer together, and it looks like a cable. At the same time, I took a second string and looped two of the loops. So I have one knot that's linked to another knot. So in fact, you have an infinite number of these, but this initial coil that wraps around that donut, it's very stiff. Actually, a better one would be here, where I have a very stiff plastic.
Oh, yes.
There's only a
Yes.
certain number of, if it was, this is plastic, it's very stiff. There's only a small number of combinations that will form that that will give you rounded edges, no intersections, and again, it has uniform properties. And at the end, it joins perfectly. That's it.
If you're, and Michael just did several demonstrations there. If you go to our YouTube channel, go to our website, thisweekinamerica.us, and click on videos, you will see the video version of this program. And it will, as Michael's talking, that will sort of further illuminate what it is that he's talking about, because it was a good demonstration and brings it home to us. Looking at your background, what inspired you to write such a series of books? One would say sort of a unique, unusual series of books.
Well, actually, as you started out in the conversation, I had this long background, initial academic background in aerospace and in biology. And during that time, much of it was focused on hydrodynamics and aerodynamics, which is how an object behaves when it's subject to vibration and waves. Now, I was never interested in knots in my life. And because in the last 35 years or so, I focused primarily on modeling environmental situations and contamination transport. But there was a time when I received, one day I had a very vivid dream. And in this dream, it came to me that I needed to find another source of energy for humanity. And I was so startled by this dream that, and profoundly startled by it, because I had no particular interest before that, or even interest in energy, that I took it as my mission, this was over 20 years ago, to start to find another source of energy to which we have overlooked. Because as you know, the primary sources of energy are either you burn something, and I call that atomic forces. We use it every day in rockets and boilers, and yes. Most of our power plants use chemical and atomic energy, atom-based energy. And then we have a few nuclear plants, which are from fusion and fission. And these two extremes, there's a gigantic gap between the very good but low-powered chemical sources of energy that we use daily, and in the other end, which is the nuclear energy, which is so extreme and so uncontrollable that it becomes a threat to society. And because of its radioactive contamination, it is sort of unthrottled energy. So it is, upon thinking of this for some time, that there would be some intermediate form of energy, something that actually took and disassociated the atomic energy that would release an intermediate amount of energy between the burning energy that's released by chemical bonds and the atomic fission and fusion. And that's what was a 20-year journey of finding, reviewing, and finding what that might be. And I have these books represent that search for knowledge and the mathematical tools and some of the philosophy that is necessary to pursue that. So my ultimate goal is to find an alternative source of energy that can be harnessed by humanity, that is substantially larger in the amount of energy it can produce, but not uncontrolled, such as in the nuclear fission or fusion processes.
How is that process coming? Do you feel like you're making progress?
Actually, very much. It took a long, long time, because many of these tools go back over 100 or 200 years that I introduced. And even though I had a strong academic background in engineering, of mechanical mechanical processes and natural processes in aircraft and aerospace devices, I found that it's scattered throughout, and that over time, many of these methods have been abandoned, partially out of neglect, and that it is very difficult to assemble. So it took a long time just to bring it together. And one of the key mathematical methods that was was made popular by Albert Einstein was the differential geometry, and it was very popular in the early 1900s. Actually, he didn't invent it, but he was associated with it and used it extensively in his relativistic theories. And then it kind of lost favor amongst the schools and has been put to the side. And there are many books on it, but it's, for the most part, not used in most curriculums anymore. So I assembled that, and that takes a large portion of the beginning. And the whole thing about knots. Knots are what I assume elementary particles consist of. I have the belief that rather than being some amorphous ball of energy that circulates, that in fact electron and the photon have a shape and a configuration that resembles a knot. And these knots have certain properties that they can either self-propel themselves or are stationary. And that the mathematics then to study that took a great deal to assemble and to put in a logical form so that anyone else who's interested in this will have much less of a problem in finding it and linking together not only that long assemblage of knowledge that's sort of been abandoned or neglected, tying into many of the theories that you listed at the beginning in quantum mechanics and superfluids, which are very dispersed areas, but have common threads. So I linked these to these theories as to where it connects to them.
Michael Ungs is our guest on the program. If you're Googling that, that's UNGS. The book we're talking about is The Theory of Quantum Torus Knots, Its Foundation in Differential Geometry, Volume 1. Michael, who is reading your books? Who are the books designed for, and why should they read them? It sounds like you're giving them a wealth of information and leading them pretty well down the path of finding an alternate source of energy.
That is exactly it, because one is that we all have a finite life.
Yes.
And remember I said that I started out in the process of many books. Over time, many subjects become sort of being taken as it's known and then sort of put off to the side and we pursue something new. And that if another person comes along and says, I want to examine all of those intermediate steps, I want to see the thread of your thought, I want to be able to sit down and pursue something differently or new, you will find it actually very difficult to do. You would have to have, literally, I have thousands of books to which I have assembled here. And that it becomes so such a weary process
Yes.
of finding all the material. What I'm hoping is to assemble sort of, I call it a roadmap, to which if you're interested in following another intermediate source of energy, and that the tools that are necessary for you to address that, and that someone who has already taken the time to link it to virtually all of the existing accepted theories, yet at the same time, I'm opening a door to a new application. That is the person would find it valuable to see this. You will not find, if you're looking for something, in 5 minutes for an answer, you may find it, but that's not the person I'm looking for. I think the person who would most benefit is, I want to find new ways. And I don't want to spend 20 years assembling that. I want to be able to do it in a matter of 6 months or a year. So it takes a patient person, but you will be well rewarded in that roadmap that's been laid there and all of the intermediate steps. You know, I do not use the word, it can be shown. I detest that word because, in fact, the people who can show that are probably not alive anymore. and you're going to find a difficult time of actually, it can be shown to have it derived in front of you and for you to review its assumptions. So at every step, I am the most critical person who reviewed this, which is I do not accept any foregone idea. I have to demonstrate it to you that it follows basic principles of differential geometry, which is the method that I follow, and show all the steps that are necessary to bring it to some useful endpoint.
Time is going by way too quickly. We're talking with Michael Ungs, the author of the series of books, The Theory of Quantum Torus Knots, The Foundation in Differential Geometry, talking specifically about Volume 1. So it sounds like in the 5 volumes, there are really some benefits to society contained in these 5 volumes. These could be a roadmap and very helpful to our future.
Yes, I agree. It's not, one has to be a patient person.
Yes.
But the world is gigantic, and the world has many problems that we need to address. And I started out by saying I'm looking for an alternative source of energy that's in between the chemical, the amount of energy that we get from chemical processes, such as rockets and burning coal and fossil fuels, and the other extreme, which is a gigantic amount of energy that we cannot control and causes enormous problems because of that amount of energy that cannot be contained. Something that's in between that. And so that takes patience for someone to get to that point and to have a rational roadmap, not one that is just cobbled together. I spent a lot of time in making all of these theories mesh together and describing pitfalls or problems that one may encounter.
You've had a recent paper.
It requires patience.
Yes, and it's taken, decades to get to this point in your work in trying to find a new way to produce energy. I know in your most recent paper on the derivation of relativity, you use airplanes as part of your idea. Talk about that. Explain that concept.
Yes. As I said, I was an aeronautical engineer.
Yes.
I have a degree in it at the University of Washington, and that I worked at a wind tunnel. And I remember very strongly that one day in the classes on aerodynamics, that the professors would always declare that the equations that you're looking at are used in aerodynamics for designing airplanes and how they behave, but don't assume that those equations are related to relativity. I took that and stuck in the back of my head all these years as to why would someone go out of their way to say, don't do something, when in fact, if you look at it, it is identical. It is identical to the equations used in relativity. And the other thing about the wind tunnel is that back then they didn't have much ear protection. And when I used to operate and turn on and run the wind tunnel as a student operator. And it made enormous amount of vibration, and the hair on your skin would just rise up as you waited for the model airplane to start reacting. Well, anyway, recently I was reading the book on the Wright brothers, and in there's a chapter about how they in order to develop a more advanced airplane, they used and created a small wind tunnel and made small sections of it. And when I read that, it's sort of like a lightning bolt struck me, and said, reminding me, don't look at this. And the other one is, it's something I can feel the vibration of air to this day, thinking about those wind tunnel operations. And when I went back again and looked at the vibration and of air, that the equations, in fact, the Navier-Stokes, and they are identical to special relativity, and that I found that there is a natural and physical process to special relativity that does not require any of the assumptions that Einstein said that are required for the theory to be accepted. I found through Newtonian mechanics an alternative that gives why his equations have to be in the form that they are. And that was an astounding. That was something that I would never have imagined possible. But it also gave me enormous hope because actually I have not published yet. I've also found how the same equations that show why these equations of relativity have to be in the form that they are, yet using Newtonian mechanics to do that. Also why superfluids and quantum mechanics, because previously to this, quantum mechanics and superfluids and have their own special box that people work in, and they've imagined the equations. They have a very difficult time linking these theories together through any single natural process. And believe it or not, that when the equations of the wave equations, it's called the convected wave equation for aerodynamics, that equation is the thing that actually links special relativity and quantum mechanics. And I don't believe that anyone has ever presented or demonstrated that. It is to be published in the near future.
It's just amazing work. I've got about 30 seconds left here, but after talking with you, I get the impression you're passionate about this and you really feel you're onto something after all these years, that things are fitting together.
Yes, because it's rather than being over this 20 years, it's very frustrating to take so long because there's so many threads of knowledge that have to be tied and linked to it to show those, why is it related to this or how can it be? At every point, rather than it being dead end, it is the opposite. It has brought closure to so many different subjects that I consider to be in another box, in another profession. But in fact, it is linked by the common thread of a fluid that is vibrating. And that is the thread in aerodynamics or hydrodynamics, Navier-Stokes equation. That is, which was discovered almost 200 years ago, that equation is that which links all of these disparate areas, and which has given me the idea that the ability to find this alternative energy rather than being frustrated by no closure, in fact, does have closure and is the path to take that to my knowledge, no one has presented in any comprehensive way before.
It's exciting, and it's the 5 volumes from Michael Ungs, that's UNGS, talking today about the theory of quantum torus knots, its foundation in differential geometry, Volume 1. Books available at bookstores around the country. I'll guide you to Barnes & Noble. You can find a link to Barnes & Noble at our website, thisweekinamerica.us. Michael, it's an exciting time for you as things are fitting together and you're getting tremendous response with the work that you've done up to this point. And it's a pleasure having you on the program. Thank you for taking the time to be on, and thank you for your gentleness in explaining to me, a total outsider on this, but it's been a pleasure. Thank you.
Thank you, Rick.
It has been our pleasure. Michael Ungs, the book, The Theory of Quantum Torus Knots, Its Foundation in Differential Geometry, Volume 1. Information on our website, thisweekinamerica.us. And we're back on today's program after these messages.
This Week in America is online. You can visit our website, thisweekinamerica.us. Scott Pinkerton, Associate Producer of This Week in America. Jay Anderson, Segment Producer. Ben Watson, Webmaster. Otto Bechet, Director of Engineering and TV Production. This Week in America produced and is a trademark of Blue Funk Broadcasting, LLC. For information on all of our guests and to listen to this week's show, our website again at thisweekinamerica.us. And I'm Sean Bratton, Executive Producer of This Week in America.